Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to discuss about document summarization or text summarization. I am using NLP to do that, and this is the 18th video on NLP. Let's start. Document summarization or text summarization using NLP. Document summarization or text summarization refers to the technique of shortening long pieces of text. The intention is to create a coherent and fluent summary having only the main points outlined in the document. Automatic text summarization is a common problem in machine learning and natural language processing. So it's simple. See why we need document summarization. These points are important. Automatic summarization algorithms are less biased than human summarizers. Personalized summaries are useful in question answering systems as they provide personalized information. Using automatic or semi-automatic summarization systems enables commercial abstract services to increase the number of texts they are able to process. Summaries reduce reading time. When researching documents, summaries make the selection process easier. Automatic summarization improves the effectiveness of indexing. These are all the different steps in document summarization. We do text cleaning, sentence tokenization, word frequency table, and summarization. Each steps, these are all part of NLP, and we have separate videos related to these as well. Even word tokenization, we have used NLTK and TensorFlow. Both videos are available. You can watch that. Anyway, I am covering those aspects. What exactly we are going to do here as well. See different tools for NLP. If you ask, NLTK, the most widely used, SpaCy, high performance. This is another tool we use. NLTK is the most commonly used. GenSim library for document similarity analysis. Core NLP, well known for its speed, and Allen NLP. In this video, I am using SpaCy. You see, pip install SpaCy will work to install that. Conda install. If you are using Anaconda, you can use this command, Python mSpaCy. This command will download all the necessary libraries from SpaCy. This is simple commands you can execute. See, softwares using in our implementation is SpaCy and Python. These two are I am using. Installations, as I discussed, it is pip install SpaCy and Python. This command will work fine. That's all. I am getting into the implementation part now. See, this is a document. I know this document. It's with me. It is it is saved in my system, and this document, it is, I can show you. I have saved it here. This is the document, ai.text. This document, I am, what I am using is, to the summary of this document only. I am trying to get it now. You got my point. I am going to summarize this document. This is a document. I copied it from Wikipedia and gives the information for artificial intelligence. So you can, it's saved from the Wikipedia. Fine. Now, I can tell you I am using the Spider IDE. This is the IDE I am using. Spider, I am using, Anaconda. I have installed all the softwares on top of Anaconda. And when you type Spider in Anaconda, you will get this IDE. Okay, fine. Now we will, start with the implementation. So I have the program with me. It's otherwise it will take a lot of time. So I just explain you the program how it will work. It's a simple program. We can try it. See, I'm importing the necessary libraries first, SpaCy, and stop words from SpaCy. I'm importing punctuation. After that, as I discussed you, I have saved D::, Tatumasi NLP document summarization. This is the location where I saved my, this is the location where I saved the document. So I am getting, I am accessing this document, from this, from that location. That's what I am doing here. After that, I am reading the document and put it inside text. That's what I am doing it. If you run this program, it will run it. That's all fine. Now, I after that I am getting the list of stop words, and I am using the NLP to NLP as well. As I will save the I will show you the code here. It is here I am going to get the stoppers. See, stoppers means, in a paragraph, in a text, there will be unnecessary words. See, what, where, how, when. Some of the words, it is, with respect to its content, it's it's not relevant. Such words we call it as stop words. So we are trying to get the we're trying to print the stop words. See, I will print the stop words here, so you will understand what is it from the document. See, I am printing these type of words. This is a related document, but if you see the this list, this stop words list, moreover same as themselves, we almost, it's not at all related to AI. See, the our document contains the artificial intelligence related information, but this stoppers is not related to AI, so we remove the stoppers from our document. That's the way we get the summary. You are getting it. That's the one first step. See, so we printed the stoppers. After that, if you see, we are using the SpaCy and we are getting the NLP. So load this en dot sorry, en underscore core underscore verb underscore sm, and by using the NLP, we passing the text is the document. We are reading the document and passing the text to the NLP, and we are getting it inside the doc. That's what we did it here. Fine, I am commenting this. You understood what is stop was, so I am commenting that part. Fine. Now we will get into the next part. See, that is the tokenization. Tokenization, there is two types of tokenization: sentence tokenization and word tokenization. We use here. I am going to print the tokens here. If you see here, again, I can print the tokens. Tokens means words. We are just splitting. That is that's what we do here. See, if you print it, you'll see all the words it is printed. See, these are all the tokens. It's we are getting it. You understood? Fine. See, uh, all the tokens, we got it. Now what I am going to do is, we can see the punctuation as well. See, that is another thing we need to remove. So that's I'm going to print you the punctuation for you. So print, I am just this one I am commenting. I am going to show you the punctuation. If you print it, you will get it here. See, these are all the punctuations. We can remove that as well. So that's what I am going to do now. See, you need to understand the first step, the different steps I told you as part of this uh, thing. It is as I told you in the document summarization, I told you the different steps. I think, see, the text cleaning, that is one step you need to understand. So the text cleaning is, you need to understand, is removing stoppers and punctuation. Here we are removing, in the part of text cleaning, you need to remove the stoppers and punctuation. So that's what we are going to do in the next part. See, here we are going to do that. And we are printing the word frequencies as well. So I will show you that code. See, word frequencies, we are creating a dictionary here with word frequencies, and for word in doc, word dot text, we converted it into lower, not in stoppers. See, not in punctuation. Then we are printing that word frequency array. So we are in this simple piece of code, Python code, we are removing the stoppers and we are removing the punctuation. That's what we are going to do here. So I will run this program, then you will understand this, what exactly run this part of the program. See, we got it right. See, the we are getting the frequencies. Each word how many times it's repeating. See, the first word computer, science 1, artificial 2, intelligence it's 6 times, right? AI it is 7 times in our document. How many times word is the frequency means the number of times it's repeating. So that's what we have done it here. So we got the word frequencies from here. After removing the stop words and the punctuation, we got the word frequency. Next part, we are trying to get the maximum frequency. So different words have different frequency, and we are trying to get the maximum frequency in this. I will run that so you will get it. See here, I'm trying to get the maximum frequency. The maximum frequency is 7. See, one word you can see here, it's coming, it has 7, that is AI. See, it's 7. That is the maximum frequency. You understood that. Now, what I'm going to do, I will, just maximize it so that you will understand this. You can see it clearly. Sure, that's fine. Now, what we do is we are getting into the next part of the program. See, that is to get the normalized frequency. Now we get the maximum frequency. So that what we are going to do in the next part of the program. We are trying to get the normalized frequency. The normalized frequency means it is to get the normalized frequency, divide each frequency with maximum frequency. Then the maximum value will be, the maximum value of normalized frequency will be 1. See, here the maximum frequency is 7. The word frequency, we got it, it is 7. And you are dividing the each frequency with 7. 7 is the maximum frequency. And we are dividing 1 with 7. Next 1 with 7, next 2 with 7, then 7 with 7. So that is the maximum. 1 is the maximum value of the normalized frequency. Let's try that. See how it will come. See, everything is less than 1. Here only one place you will get 1. See, AI you got it as 1. That is the maximum normalized frequency. Here you can see for AI it is 1.0, that is 1. All other the normalized frequency is less than 1. We got the normalized frequency. After that, what we are doing is the sentence tokenization. I told you, a paragraph or any document can be word tokenization. You can do sentence tokenization. If you want more clarity, I have separate videos for word tokenization using NLTK. Here we are using SpaCy, and even with TensorFlow, we have in the playlist NLP. This is the 19th video. You have all these things. You can watch those videos. You will get more clarity. See, here we are doing the sentence tokenization. See, just I will run it for you. See, this is the sentence tokenization. Yeah. So we have printing the sentences here. You can see last you got the sentence tokenization. Here we are getting the sentences. How many sentences are there? We got it. Now what I'm trying to do here is the most probably we have to sentence score. That is another important thing. The sentence score is each sentence, what is the weightage of each sentence. Even in the TF-IDF algorithm, the weight of each word is given by TF-IDF algorithm. Here we are calculating the sentence score by this piece of code. I will tell you, explain you how it is. It is same as that of word frequency, the same method only, same code only, same way only we are doing it. You need to understand calculating the sentence score for each sentence is the same way as word frequency, because we have normalized frequency for every word. See, normalized frequency I discussed you, its maximum value is 1. For each word normalized frequency is there. We are adding the normalized frequency here and getting the important of each sentence. The sentence score gives the importance of each sentence. So each sentence will be having a score. Based on that, higher the score, that sentence is more important. So the same way we implemented word frequency, the same thing only we are running it here. We are doing it here. I am, sentence score. It's a dictionary in tokens, text flow over word frequency. After that, sentence score dot keys. After that, we are, sentence scores by, word frequencies, word dot text flow over, and again we are adding that the same method only. It's a simple Python code. We are running it, so you will get the sentence score here. See, you can see it here. It is, the each sentence we got a score associated with each sentence, so you can see it. Now, what we are trying to do here is now we need to get 30% of sentence with maximum score, and it is done by the heap queue. So we need to import that. So now we need to get 30% of sentences which, so we are summarizing the document. That's what we are going to do here. Uh, Now we need to get the 30% of the sentence with maximum score by using heap queue. So from we are importing that, and we are trying to get the summary after that. I will show you. It is here. You can, from heap queue we are importing the n largest. So to see, we got the score of each sentence. After that, what we are trying to do is, by using, we are getting the 30% of the sentence with maximum score by using heap queue. From heap queue import n largest, select underscore length int length sentence underscore here into 0.3. So 0.3 means 30 percentage. After that, we are printing the select. So length, select underscore length. Then summary is n largest. It takes a select underscore length sentence scores, and key is equal to sentence underscore scores get. So that will provide you the summary. So now I am, printing the, you can print the summary. Then after that, you will get the summary of, this thing. I'm printing summary as well. Now let me see how it will. See, now we got the summary. You can see it here. The paragraph we have given, it is, this is the summary. Sorry, this, you can see it here. This is the summary. This is the summary. That's what we got it. Even if you print, see, if you want, you can print the text. That means that's the document we have given. If you print the text, it will be like, it is it will, the entire document. See, if you are printing the text, I can show you here. Print here. I am text. That is the document we are using. I will show you here. I am commenting all these things. It is then you will understand what's our document, and how it, after summary, how we will get it. See, now I am, running this. So now you can see the document. See, this much is there in our document. You are getting it. So this is the input to our program. So this much is there. Now we are, doing the documentation summary by using NLP. And after that, when you run this program, and one more thing I can tell you is, we will calculate the length of those summary and the document as well. Then you will get more clarity how much it is reduced. That we will show, I will give you. So print summary. So this is the final summary. Word dot for word in summary, summary dot join final summary. We are getting the final summary here. For that word dot text for word in summary, then summary is equal to join final summary. After that, I am printing the summary here and getting the C to make you understand. Here I have put this dot dot dot, then I am getting the length as well. So you can see it here. Now the length of this text is 1356. Now the length of the summary is 720, and you can see the summary here, this dot dot. See, after this dot dot, it comes. See, even if you read it, it's you can understand. In computer science, artificial intelligence, AI is sometimes called machine intelligence, as intelligence. It's the core points. That is the sentence core. The most important points are displayed. See, if you see the text here, it is, it's written here. This is the input. I think I can show you. It is. It's printed. I can show you the document itself. It's opened in with me. See, this is the document. So this, from this document, the most important points, it is summarized in our program. If you read this is from Wikipedia only. I copied, related to artificial intelligence. And if you see this document and the summary we get, it is, the most important sentences are, written here. If you read this in computer science and artificial, sometimes called machine intelligence, is the intelligence demonstrated by machines, unlike natural intelligence displayed by humans and animals. A modern machine capabilities generally classified as AI include successfully understanding human speech. See, the most important sentences here, leading AI textbooks define the field of the study of so those things and all, it's not included. So the most important sentences are, got it from this document. That's what, the program is doing. So that's all. Thanks for watching. Please like, share, and subscribe. Thanks a lot.